going to be graphing the graph f prime of x over the domain -7 to 7.
What do you mean? When you nod your
Part A of the question states, find all values of x for -7 to 7 at which f attains a relative minimum. Justify your answers. So this graph has two relative mins and max. So there's a relative min over here at x equals -3. And there also, wherever there is a relative min or max, there's a horizontal tangent. So there's a horizontal tangent at x equals -3. There's also a relative max at x equals 2. So we know the horizontal tangent exists. And there's also a vertical tangent at x equals 3. X equals 3. Okay, so wherever there's a relative minimum, the graph is going from negative to positive. And the only place on the graph where going from negative to positive is at x equals -1, because it's negative for the lower quadrant, and then as it passes through -1, it gets to the upper quadrant, so it's going from negative to positive. Therefore, a relative min exists at x equals -1, because f prime of x is going from negative to so since f prime of x is increasing and decreasing at x equals -1, there is a relative min for the original f of x at x equals -1.
Question B is to find where f of x has a relative maximum. The relative maximum occurs when the graph goes from being positive to negative. The only place where that happens is at x equals -5. X equals -5 because f prime of x is going from positive to negative.
Part C is asking for all values of x from -7 to 7 at which f double prime of x is less than 0. So it's asking when the second derivative is negative. So the second derivative is negative when f prime of x is decreasing. So the values for when f prime is decreasing is from -7 to -3. So the first answer would be -7, -3. That's one area on the graph where f prime of x is decreasing. You also have f prime of x decreasing from 2 to 5. However, something funny is going on. There, a vertical tangent exists at x equals 3. Therefore, f prime of x is undefined at x equals 3. So what we have to do is you have to break the intervals up. So you would have f prime of x decreasing from 2 to 3. You would also have f prime of x decreasing from 3 to 5. So f double prime of x is negative or less than 0 when f prime of x is decreasing, or the interval is -7, -3, 2, 3, and 3, 5.
So, part D is asking us to find the absolute maximum. So we knew from part B that there is a relative maximum at x equals -5. So we know the absolute maximum can be at x equals -5. We also know that an absolute maximum can occur at the two endpoints, which is x equals -7 and x equals 7. So we know that f of -5 is greater than f of -7 because f is increasing from -7 to -5. So, the graph of f prime shows us a negative change in f from -5 to -1, which is much smaller than the positive change of -1 to 7. So, from this, we know that f of 7 is greater than f of -5. So this leads us to believe the absolute maximum is occurring at x equals 7, one of the endpoints.